Hello guys, and welcome to the first day of Polynomials. This is Chapter 8, Day 1. Let's get started. So first off, we are going to start with a whole bunch of vocab. Now the good news is most of this vocab you already know, but since we're starting a chapter called Polynomials, we gotta go over this. First off, the chapter name, Polynomials. Break it down. Poly means many, nomials means number or terms. So this chapter is about expressions or equations with many terms. A brief review over monomials. Think about it again. Mono means one term. All of these in this left-hand column, all of these are monomials. A number, a variable, a product of numbers, or a product of all of them. Remember, on this one, the variable cannot be in the denominator. That may or may not be how you spell that word, but I stand by it. So the variable can't be in the denominator. We'll get to equations like that later in the semester, but for right now, monomial, no variables in the denominators. Over here, your non-examples, well, we have exponential equations. You have sums. Okay, whenever you have a sum, or I'll add in here, or difference. Okay, if you're adding or subtracting, that's no-go with monomials. Negative exponents, because that puts the variable in the denominator. And a quotient. Again, variable in the denominator. Okay? So, take a brief moment, look at the examples down below. Video is going to pause, see if you can name whether they are a monomial or not. Go for it. And how'd you do? Remember, with 3 and 4, whenever you have a fraction, the numerator is almost being multiplied off to the side. So for 3, you can have a fraction in the numerator all you want, because that's going to be x times the fraction of 1/5. But with 4, you have that negative exponent, which pushes the variable into the denominator. All right, with that being settled, let's discuss polynomials. Now, polynomials are the sum or the difference of more than one monomial. Okay, kind of like that example up in the beginning of your list where you had x squared plus 3. That was an example of a polynomial. Two things being added together. Okay, so take a moment, try to guess whether these down here at the bottom, 6 through 11, are polynomials or monomials. Should be pretty quick for you. Go. Okay, how'd you do? All right, if you put yes for number 7, good thought. However, remember, definition of a polynomial is more than one monomial. And a monomial cannot have a variable in the denominator, so that takes 7 out. Now, there are two main types of polynomials that we'll be dealing with and that you'll be seeing basically the rest of your math career. And that's binomials and trinomials. Okay? Break the word down. Binomial is the sum or difference. I'm going to start shorthanding here. Difference of two monomials. Whereas a trinomial is the sum or difference of 3 monomials. Okay, the little plus sign and subtraction sign, my shorthand. You can write the full words out, but there's my shorthand. So examples of this. For a binomial, you got x plus 1, you've got 2x squared minus 3x. As long as it's only 2 monomials being added together, you're good. And for a trinomial, same rules, you just have 3 terms. So x squared plus 2x plus 5, 3x, 5 to the 5th power, plus 17y minus 5. There's a lot of 5s in here. You can have fractions. So you can have 1/2 x cubed plus x plus 2. So you can have fractions. There just can't be a variable in the denominator. All right, go ahead, down here at the bottom, see if you can figure out whether it is a monomial, trinomial, binomial, or just not a polynomial at all. Go. Okay. And here are your answers. So make sure before you name anything, like on number 13, you always combine like terms, because that could affect your answer. Always combine like terms. And then for 14, again, the variable in the denominator cannot be there. Small note on the combining like terms thing. Just a few reminders. Number 1, x squared and x are not like terms. They are separate. Okay? Think classification of seniors, or classification of students. You've got seniors, and you've got sophomores, and you've got juniors, and you've got freshmen. Okay? They're all students, but the classification is different. Therefore, when you group them, they're going to be different. Likewise, x squared and x. Yes, they have x in them, but x squared has a higher power than x does. All right, and on that, let's keep going. What I want you to do 16, 17, and 18, or 16 through 19, and when the video plays again, we'll talk about this next term. Okay, and here are your answers. Again, notice the combining of like terms. But to add on to that note, I also want you to notice how there are a few times, looking at number 16 specifically, where I rearrange the terms. Okay? This is because the degree of the monomials. Okay? And this is also the same thing that goes back to combining like terms. You can only combine terms if they have the same variable and the same power. Okay? This power could also be called a degree. Now, the degree of a monomial is the sum of all the exponents. Okay, all the exponents in a term of all the variables. Okay, you add up all the exponents of all the variables. For a polynomial, it's just the degree of the polynomial is the degree of the greatest monomial. Let's practice. So for 20, that is a monomial. So I'm going to add up all the powers of my variables. So that's going to be 1 plus 2, which is a very obvious 3. The degree of this monomial is a 3. But when I go over to 22, it is a polynomial. So I'm going to ignore this one back here and just look right at this first term. Okay, the degree is 2, therefore my degree is 2. Small note here, I'm going to change color so you can see what I'm talking about. 3. 3 is called a constant. Okay, anytime you have a number without a variable, it is called a constant. The degree of a constant is 0. And that's just how it is. It's just something you got to memorize. All right, your turn. Go ahead and do 24 through, or 21. So, well, do the last 4. All right, make sure you pay attention to if there are any combining like terms, because that might change your answer. When the video pauses, go ahead. Okay, how'd you do? Now, for numbers like 23 and 25, these are highly special cases. And what makes them a highly special case is that we have multiple variables in the same equation, or expression in this case. For the most part, this won't happen. I just wanted to have it here so that you can see it and you can understand the technical definition. But for the most part, when we go up to binomial and trinomials, we will only be using the one variable. So you won't see cases like this very often. Now, the reason why we learn about this degree stuff is because of ordering our terms. If you think all the way back to when we did standard equations, okay, we had ax plus by is equal to c. There was a unique order to the expressions and to the equations, and it had to be in that particular order because the order of the expressions does stuff. Okay, it allows us to order our problems and keep solving. So order matters. When you are arranging your polynomials, you want to do it in descending order. Why do I have a black It's so weird. Anyway, you want to do it in descending order. And then typically, because we always graph with x, we do it to the power of x. But if you didn't have a specific x value, if you just had a and b, for example, you're going to do it in alphabetical order. So let's do this first one. Notice how I have a power of 3 back here. Take the negative sign, don't ever lose your signs, and you're just going to rewrite it. So negative 2x cubed x plus 6x squared minus 8x, and last but not least, plus 5. You're just rearranging things. And you want to do it with the x powers going in descending order. Your constants should always be last. If you don't have a constant, then just end with the other variable, because that'll happen in a few cases. For example, let's do d over here. Okay, so we're looking at x, descending order of x. There's an x, no x, there's an x. Okay, so this right here is our highest power of x. So I've got 4ax to the 5th. Then I'm going to go to this one, minus a to the 4th. Whoops, nope, that doesn't have an x in it. Got tricked. We're going to go to plus 3a cubed x squared. That's the next power of x. And then plus 9a squared x. And then last but not least, the a to the 4th power. So in this instance, we don't have a constant as a last term. We just have the a that's all by itself as our last term. And that's okay. It doesn't matter that it's to the 4th power because we were ordering these things in terms of x, and this is the first one that doesn't have an x. Your turn. Go ahead and do the rest. All right, here are your answers. If you have questions, please let me know. Otherwise, let's keep moving. All right, now we get to the main event, adding and subtracting. So the whole reason for all of this buildup, recognizing like terms, recognizing powers, is we are going to add multiple polynomials, add and subtract. Now notice that right now, we're not really dealing with any equal signs, okay? Which means that we're not solving. Thankfully, because we got more than one variable going on here, but these are all expressions. So the only thing we're doing right now is simplifying, combining like terms. So when you start to do these, it sometimes helps when you have a lot of them to underline or to mark them in some way. That way you can recognize off, just by looking which is which. So here we have an x, and here we have another x. Make sure you don't forget your signs. So this is going to be negative 3x. Here's our y, plus 2y. Let's do one more. Number 2. Okay, go by the powers. So x squares goes first. There aren't any other x squares, so that one just hangs out up front. This is the only other x, so that one just tags along. And then we've got 2 y's, so that's going to be a negative 6y. So make sure that as you do these, you always rewrite your terms in descending order of power. And if you don't have an x, go alphabetical order with your variables. Do the other 3. And how'd you do? All right, now those were the simple ones. Those were the ones where it's very obvious, it's all nice and laid out. The biggest distraction here is making sure you don't mix up powers. Let's add a level to it. Now, if you look over all these problems, you'll notice that there's a parentheses. Don't let that freak you out. For the most part, it's just telling you that you're adding this whole polynomial to the other polynomial. But all you can do is combine like terms anyway, so it doesn't really change what you're doing. Except in the cases where you have a negative sign. And we'll deal with that one in example number 4. So I'm going to do example 1 and example 4 with you. Let's do it. All right, example 1. Start with the highest power, and that's going to be x squares. So I have a 3x squared and a negative 7x squared, which is going to be a negative 4x squared. 4x plus 2x is going to be a negative 2x. And then 8 plus negative 5 is going to be a positive 3. You'll find that with a lot of these really, really big expressions, there's just a lot of instances of the same term. It'll all boil down into a trinomial, maybe 4 terms, but for the most part, a trinomial or a binomial. So just be very careful as you go through and find your like terms. Now, number 4. Here's the tricky part. But we've done this before, so I trust you. The negative sign. In the first problem, we were adding both together, so signs weren't changing. In this one, we are subtracting one polynomial from the next, so signs are changing. Make sure you distribute. The negative has to go to every single term, and it will change the sign of all the terms. So the first thing I'm going to do is rewrite this whole expression. But now that I've distributed my negative sign, the negative drops away. Now that I have all of my signs in the second part changed, I can do the same thing and just combine like terms. But again, start with your highest power. So y to the 4th, negative 9y to the 4th. So we have a negative y to the 4th, y squared, negative 2y squared. It's going to be a positive 4y squared, negative 5y, and positive 7, so plus 2y. Okay, keep going. Do the other 4. Sorry, the last 6. So you're going to do the rest of the examples and then the last 2 problems at the bottom of the page. Good luck. Okay, and here are your answers. How did it go? Now, a small note for examples 3 and example 6. For example 3, I decided my order based on A. So I have the highest power of A up front, and then I go to the next highest power of B, which is why the B cubed got up front. Now in this particular instance, it looks as though I'm going in descending power of B, but I went with A. With example 6, don't get thrown off by the 3 rounds of parentheses. Once you distribute the negative, you can drop all the parentheses because now you're adding and the signs don't change. The parentheses are there to remind you that you're combining this whole polynomial and this whole polynomial. And the biggest way that they do that is by forcing you to distribute the negative. So once you've done that, all the parentheses can go away. All right, let's keep going. All right, let's mix things up a little bit. Adding and subtracting is all well and fun, but let's do these types of problems. On these, we're trying to find the perimeter of the figure. Now, the perimeter of the figures, as a reminder, is when you add up all the sides. You've probably done this before, but have you done it when the sides are polynomials? Let's see. So I'm going to go in a diagonal line. I'm going to do these 3 problems. You're going to do them with me, and then you're going to do the rest. So starting with our triangle. Remember, you're adding all the sides. So if you want to just look off of the shape, that's fine. I'm going to, for this problem, since it's not that many terms, write it all out in a line. So that's going to be 4x minus 8 plus 3 minus 2x plus 11 plus y. Now, as I'm doing this, if you can just look at it and tell from the shape, that's completely fine. I still want you to show some kind of markings on the picture themselves, and I'll show you what I mean in a second. Right now I'm just combining like terms, and we have plus 6. Again, the constant goes in the back. So for those of you who want to do this in your head, or you don't want to do all of the rewritings, you know, here's an x, here's an x, have some sort of marking. It just makes sense and it helps you out. I realize it's extra writing, but the more stuff you do in your head, the more likely you are to make an error. So if you can write down these small little cues, it really helps you out. All right, let's go on to the next one. Now this one is fun because we're not given all of the sides. So we're going to do something different on this one. This shape is a rectangle. So what do we know about rectangles? Well, rectangles, to use geometry language, They are congruent on both sides. So the top is 7 plus 3x, the bottom is 7 plus 3x, which means that this is 5x squared minus 2. But that's a lot to write. So when I do my equation, what I'm going to do is say that I have 2 of 7 plus 3x's, because I do. Here's 1, here's 2. I have 2 of them, plus 2 times 5x squared minus 2. And you're allowed to do this. You can group them together and you can multiply. So here I'm going to distribute, and I've got 2 to the 7 and 2 to the 3x. Biggest reminder here is just to remember to go to all of the terms. Don't forget any. And now once you've got this, you can combine like terms. Leave the highest power up front. And there you go. If you did it the long way, did our answers still match? They should have. This is just a nice way to condense your work, and sometimes it cuts back on those addition and subtraction mental math errors. All right, now this one I am going to do by marking up the picture. So for all of you who are marking up the picture, I'm going to do this one that way, just because this is going to be a massive expression if I were to rewrite it all out. So x squares first. 3x squared, 5x squared. So 3 plus 3 is 6, plus 5 is 11. 11x squares. All right, now there's a lot of x's, so I might break down and write these out. We've got 4x plus 2x, so I'm going to make that a negative 6x. 4x, negative 2x, again, another negative 6x. And then last but not least, a 7x down here. It just occurred to me, I wasn't saying my signs. So this first one was a negative 4x and a negative 2x. Don't lose your signs. Okay? Take them with you. And then last but not least, I've got a 3 and a positive 7 and another positive 7. So 7 plus 7, that's going to be 14. Plus 3 is plus 17. Did I forget anything? Nope. All right. And that's why you mark up your picture. There's a lot going on. Mark up your picture. That way you can look back and check. Now to add this up, negative 6 plus negative 6 is a negative 12. Plus 7x. That's going to be minus 5x plus 17. All right, make sure you do the rest of the problems. The video will pause and then you'll see the answers. All right, I won't show you the work, but I'll show you the answers. If you have any questions, please let me know, and have a good day. And here are the answers. Before I go, I want to point out the square, this one right here. The way I did it was by remembering that squares, all the sides are equal. So I multiplied 4z plus 3 by 4, and that's how I got my answer. If you want to add up all 4 sides, that works too. All right, if you have any questions, please make sure you mark it so we can answer when I get back. Otherwise, again, have a good day.